Let's analyze and solve the valid palindrome coding problem. We are given a string S that consists only of printable ASCII characters, and we have to return true if S is a palindrome, otherwise we have to return false. A palindrome is a sequence that reads the same backward and forward. So in this problem, what we are being asked for is to only account for English letters and treat them in case-insensitive manner and digits. And the other characters from the point of consideration whether the string is a palindrome or not should be ignored. So talking about code, we have to write a function. Let's call it isPalindrome. The function will receive a string, our input string. This is the string we have to test, and it will return a Boolean value true or false depending whether the S is a palindrome. We are also given a set of constraints, and they are pretty much the same what I already said, except what we can notice that string is never empty, so string will have at least one character. Key points for this problem are that we only care about digits and letters. We treat letters in the case-insensitive manner, and we also consider empty string to be a palindrome. And that's pretty much our problem. To solve that problem, let's first think about brute force approach. So let's use an example 2 as our test case. Let me write it down. And what we can notice from the description of the problem that we will have to ignore all the characters different than letters and digits. So exclamations will be ignored, all spaces will be ignored, the comma will be ignored, and another space will be ignored. And then we have to treat the letters in the case-insensitive manner. So we can, for example, convert them all to lowercase or to uppercase. It doesn't matter. So the first approach, brute force approach, will use that observation. And what we will do, we will first filter out all the characters that are not letters or digits. And that's the first step. So let me write it down. And then what we can do is to convert all uppercase letters to small case. So we can, in our case, it's just N. And as a final step, we can reverse the string. And if we reverse that string, we will get the same string. And the result of our algorithm will be to compare those two strings. And if they are equal, that means the original string was a palindrome. And if they are not equal, that means that string wasn't a palindrome. And the time complexity for this method is O of n, where n is the length of the string. And space complexity is O of n also, because we have to create a number of copies of the original string. And that's pretty much the idea behind the brute force solution. The brute force solution works, but we can do better. Specifically, we can find a solution which does not require additional space. So we can find a solution with a complexity of O of 1. And the way to do it is to use a technique called two pointers. And this technique is as follows. We will have two indexes. One will point initially at the first character in our string. We can call it left. And the second one we will point at the last character of our string. We can call it right. And our algorithm will be basically going in a loop until left is less than right. So until those pointers meet. And the way it works, first we will convert any capital letter to a small letter. So in this case, this will be converted on the fly to small n. And then we will move to the right. We will ignore any characters that are not letters. So we will ignore this one, we will ignore this one, and the right will be positioned over n. And then we will compare the two characters pointed by those two pointers. And since n equals n, That means that the first characters match. So we will move to the next one, and this one will move to the next one, and the process will repeat. So if this is a letter, we will make sure it's a lowercase letter. If this is not a letter, we will ignore it and move to the left or right as appropriate for a specific pointer. And once we position those two pointers over the letters, we will compare whether the letter is the same letter. If they are not, then we will immediately return false because this is not a palindrome. If they are equal, then we will continue the process. So in this case, I can quickly go through it. O is equal, so we will go to the space, but the space is going to be ignored. So we will stop on the letter L. This one will also move to the letter L. These are equal. We will move on the left side to the point to the letter E. On the right side, we will also move to the and point to the letter E. They are again equal. So we will move on the left side to the letter M and move on the right side to the letter M also. They are equal. So we will move and point to the letter O on the left side. And then we will here ignore the space. So we'll point to the space, but the space is going to be ignored. We will move again. We point to the letter O. We have two letters. We compare. They are equal. So we will move and position left pointer so it points to the letter N. We position the right pointer also so it points to the letter N. They are equal. So we will move the left pointer and it will be pointing to the comma, but we are ignoring comma. So we will move it again. It will be pointing to space, but we are ignoring space. So we will finally move, and those pointers will be equal. And since the condition was that the left must be less than right, we will exit our loop. And since we didn't find any mismatches, we will return true. And that's the gist of the algorithm. The complexity of this algorithm, time complexity is again O of n, because we have to process each and every character in the string, but we are not using any extra memory, so our space complexity has improved and it's now O of 1. And that's the gist of this two-pointer algorithm to check whether a string is a palindrome. Let's write the code for our two solutions starting from the brute force solution. So I'm going to define a filtered string variable, and I am going to reserve the size of that variable so it matches the input string S. And now we will process all the characters from the string S and filter them out. So to find out and filter out all the characters that are not alphanumeric, I am using a standard library function is alnum, which is defined in the module cctype. And now we are going to push those characters, which are either letters or numbers, into our filtered string. And when we are pushing them, we will also call toLower on all of them, so we will convert any uppercase character into lowercase character. Now that we have our string ready, our filtered string ready, we have to reverse that string. So let's create a reverse string variable. And let's initialize it with our filtered string. So those strings are now equal. We have to reverse the reverse string before we can compare them and check whether they are palindromes. For that, we are going to use a standard library reverse algorithm. This algorithm takes a range as two arguments, so the begin and end. We will call reverse string.begin and reverse string.end, which means we are going to reverse the entire string. And the last part is to simply compare those two strings and return the result of the comparison. And that's our algorithm. Let's try to build it. It builds okay. So now let's try to run the tests. the tests are passing. So we successfully coded the brute force algorithm for this problem. Let's now write a code for our optimal algorithm that uses two-pointer approach. So we will need those 2 pointers. We will initialize left pointer to point to the first character and the right pointer to point to the last character. Now that we have our 2 pointers, we can write a while loop. And the condition in that while loop will be that left has to be less than right. In other words, we will be processing the characters from the left and from the right, comparing them until the pointers meet. So let's first write a logic for the left pointer. And the logic is that we have to skip over any non-alphanumeric characters. So we will have another loop. And in that loop, we also have to check if we are still within our boundaries. So if the left is less than right. And also we have to check if the character pointed by the left pointer is alphanumeric character, or if it's not alphanumeric, then we have to ignore it. So, and if it's not s of left, then we have to skip over it. So plus left. And then we have to do the same for the right pointer, but the moving of the pointer will be in a different direction. So we again have to check if left is less than right, but here we will be checking right. And if this is not alphanumeric character, then we have to skip it and we have to decrement the right. And when we reach this point, we can just check whether the characters match. But when we are checking, we have to make sure to call lowercase on both characters and compare lowercase characters. Or we could call uppercase, doesn't matter. So if standard to lower s of left is different than standard to lower s of right, then we found a mismatch, so we can just return false. Otherwise, we have to move the pointers, so plus left, minus right. And this while loop will continue until we process all the characters or we find a mismatch in line 20. If we reach past the while loop, that means that all the characters matched and we can just return true. And that's the optimal algorithm. Let's try to build it. It builds correctly. So let's now try to run the tests. And all the tests have passed. So we have successfully coded our optimal algorithm for the palindrome problem. As a final step, let's make sure that our solutions are passing all the LeetCode tests. So I'm going to first copy the brute force solution. Let's see if it runs. It runs. So let's try to submit that solution. And submission succeeded. So let's now try the optimal solution. I'm going to paste it in. Let's see if that solution runs. It runs. Let's try to submit this one. And the submission was successful. So our both solutions work well in LeetCode. That's the end of this solution. The source code is available in the GitHub repo shown on the screen.